All right, hello, this is Mr. Wallace with a few more math problems for review that we are doing. This is in our first unit. It is on page 9. I'm going to do numbers 6 through 10 for you. This is solving equations and inequalities, multi-step, and we will get started. So this is numbers 6 through 10 starting on page 9 of our unit 1. So, okay, number 6. As always, first thing we always need to do is look and see what we're trying to do, and we're trying to solve for that x right there. So I'm just going to, a little habit. That's what we're solving for. So we need to do a few things. We need to get that x by itself. So we notice to the side here, it's a negative, that's a minus x. Technically, it's a negative. We want to get rid of that 13 first and move that 13 over to the other side. A rule of thumb that I personally like is, especially dealing with inequalities, I always like to have my x on the left side, just because it's easier to graph, I would imagine, after we get the solution. So I'm going to move that 13. That's a positive 13, so I'm going to subtract it. Minus 13 on both sides. So that cancels out. I'm left with negative x. That's still a negative right there. We have to be careful. 33 minus 13 is 20. And then we still have our greater than or equal to sign right there. Now be careful, because a lot of people would think, oh, the x is by itself. It's not. We still have that negative out in front of it, which is technically a negative 1. So to get rid of that negative, we'll just, I think, to divide each side by negative 1. Or you can technically multiply each side by negative 1. Same thing here. So those negative 1s cancel out, because negative and negative make a positive. Now we have positive x. Right? 20 divided by negative 1, sorry, that's going to be a negative 20. One of the key things about inequalities to remember is that whenever we multiply or divide by a negative number, that sign flips. It is one of the rules of algebra, right? So the inequality sign, the inequality symbol flips. So it's a greater than or equal to sign. My final answer is now x is less than or equal to negative 20. There's our answer. Now in graphing it, we look, I think you can see on the graph right here, here's our 20. So whenever we have our solution, I always teach, hey, let's go to that number first, all right, and then just circle it. Then we ask ourselves, is it an open circle or a closed circle? It is a closed circle, because we have our equal to sign underneath. This means that it is less than or equal to, so it could be either or. So that's going to be filled in there. Closed circle on the 20. And this is why I like the x on the left side, because that arrow kind of gives us a hint of where to go. If it's pointing to the left, that means my graph is going to the left. So I'm going to have a little arrow like that. If we read it, x is less than or equal to negative 20. Less than means anything that's on the left side of the number line. So negative 30, negative 25. Because they're negatives, those are technically less than still negative 20. All right, there's number 6. Let's do number 7. This one's a little tricky because we have a fraction here. X over 3 minus 7 equals negative 2. Let me see if I can focus real quick. Sorry about that. Oh well, I think you'd hopefully be able to see right there. What I like to do when there's a couple things outside of the fraction, I like to do a little parenthesis around the fraction and see if there's anything outside that we need to get rid of, because that's the rule first. If we have a fraction and there's a plus or a minus or something outside of it, we need to get rid of that first. So that's a minus 7. I'm going to plus 7 to get rid of it. Boom. Plus 7 on both sides. I'm going to rewrite my equation. X over 3 equals, this is not an inequality, it's just an equal sign. Negative 2 plus 7 was the same thing as 7 minus 2 is positive 5. Now I just have x over 3 equals 5. There's multiple ways we can think of this. What number divided by 3 would equal 5? Well, in my mind, I'm like, okay, 15. But algebraically, if we wanted to get that x all by itself, we just multiply both sides by the 3. Boom, boom. Multiply both sides by the 3. X equals 15. A few different ways to think of it. And that's number 7. All right, number 8. Here we go. So it's kind of, once again, a little tricky. If we have a fraction, put a parenthesis around it. Now, Is there anything outside of that parenthesis on that side of the equation? No. Unlike there was right here, if there's nothing on the outside of the parenthesis, we can immediately try to start getting rid of that fraction, right? We have 6x divided by 14 is less than 3. I always want to get rid of the denominator first, and so the denominator is the bottom number. If there's a 14 on the bottom, first thing I want to do is multiply both sides by 14. Now be careful, don't multiply the 6 by the 14, because what happens when I multiply both sides 14, those 14s automatically cancel out, right? And then we're left with 6x, right? 6x by itself is less than, let's see, 3 times 14, if I do it on my head, it should be 42, right? I'm going to just double check. 14 times 3, yep, 42. Okay. Now comes kind of the easy part. One more step. If I want to get that x by itself, when a number and a variable are always back to back, it means multiplication. I'm going to divide by 6 on both sides. Those 6's cancel out. I am left with x is less than 42 divided by 6 is 7. Right? Now, did we divide or multiply by a negative number? No. So the symbol stays the same, unlike number 6, where we multiplied or divided by a negative, where it switched. This is dividing by a positive. Doesn't matter if we divide, it's a positive, so the sign stays the same. The symbol stays the same. Now let's graph it. Go to that number 7. Where's 7? Right here. I'm going to circle it. Is it open or closed? It is open because there's no line underneath. It is a less than sign. X is less than 7. Think about it. All these numbers to the left are less than 7. And there is number 8. All right, 2 more for this review real quick. Number 9 and 10 on the other page. All right, number 9. There are a few different ways we can do this. I'm going to distribute. Right? There are 2 ways to do this, really. I always love simplifying with the distributive property. It's one of my favorite properties to get rid of those parentheses. So whenever we have any value, number, variable outside the parentheses and it's next to a quantity in the parenthesis, I can distribute. Double rainbow, as they call it. So that's a -2. Whenever you distribute, it is multiplication. -2 times x is -2x. -2 times -7 is +14 equals 12. All right? We've got to turn this into a 2-step equation now. We're solving for the x. Right? I have to get rid of whatever's happening outside this term right here. This -2x, I want to look and see, is there anything being added or subtracted outside of this, and there's that +14. So I want to get rid of that +14 by subtracting it. Both sides, 14s cancel out, it's done. Rewrite my equation. Always be in the habit of rewriting and simplifying your equation. So now I have -2x, that 14 is gone. 12 minus 14, so 12 in the positive, 14 in the negative is -2. One last step to get that x all by itself. Divide by -2 on both sides. Negatives cancel out. Negatives cancel out and makes a positive. X equals +1 because -2 divided by -2 is 1. Okay, very last one. Here we go. Thank you guys so much. I have a fraction. I'm going to put a parenthesis around it. Is there anything outside that fraction, outside the parenthesis on that side of the equation? Yes. We have to get rid of that +10 first. So I'm going to subtract 10, do the opposite operation. That cancels out. Subtract 10 over here. Rewrite my equation. X divided by -3 is greater than or equal to, what's 11 minus 10? Oh, hard one here. Just kidding. It's a 1. All right. I need to get that x by itself. This fraction means it's being divided by -3. So to get rid of a dividing of -3, a division of -3, I just multiply -3 on both sides. Multiplication, division cancel each other out there. Multiply 1 times -3, which would just be -3. Here we go. Let's have our answer. That x is now by itself. X is by itself. Did we multiply or divide by a negative number? Yes. So that sign changes. And it just happens to be a less than sign again, which is fine. 1 times negative 3 is negative 3. Let's graph. Go to that number, negative 3, first step. Circle it. Boom. Is it an open circle or a closed circle? Well, with my equal sign underneath the inequality, it is a closed circle. This is a less than sign, and it's pointing to the left, so everything to the left right there. So, all right. Thank you, everyone. Appreciate it.